Hi everyone, welcome. I had a few people asking me about some linear programming stuff. Um, Maybe you missed class, or maybe you just wanted to talk a little bit about how to do some of these types of problems. So I figured that I'd run down through a little bit of a couple of the problems that we've done in class, just briefly, and then I'm actually going to use the answers that we have, where we kind of can talk a little bit about them filled in. So first off, what is linear programming? It's a way to find your minimum and maximum values whenever it comes to specifically profit. Um, we use something called an objective function, which is a new function, something that's not an inequality, in order to get those numbers. You're going to hear some terms called constraints. Those are just the inequalities that you use in the problem. And then you're going to hear something called feasible region, which is the overlapping shaded region of intersection. Up until this point, you've probably done both of those. The objective function is an equation that optimizes the profit. As I said before, that's the new thing. So if you take a look here at example number 1, Max is a farmer who plants corn and wheat. In making plant decisions, he uses the 1996 statistics from the United States Bureau of Consensus. Mr. Desmond wants the plant according to the following constraints: no more than 120 acres of corn and wheat, at least 20 and no more than 80 acres of corn, and at least 30 acres of wheat. The first thing that we want to do is we want to make sure to define our variables. So in this case, we're going to let x be our corn acres and y be the number of wheat acres that we have. After that, we want to find some constraints. If you look here in these statements, we've got keywords such as no more than and at least, no more than, and at least. Those mean that we're going to have some type of inequality that we're going to have to set up. Now, the first one says no more than 120 acres of corn and wheat. So it'd be x plus y is less than or equal to 120. Then at least 20 and no more than 80 acres of corn. So x is greater than or equal to 20, but x is also going to be less than or equal to 80, and at least 30 acres of wheat. So as you can see here in my constraints, I've got all those in there, and then of course I've got those ones that aren't mentioned. X is greater than or equal to 0, or y is greater than or equal to 0. Those ones are not specifically mentioned, but just remember that whenever we have a negative, whenever we have these types of word problems, there are no negative solutions. Next, I want to look at my objective function. I'm going to create the objective function based on the yield per acre and the average price. This one is a little different from others that you'll see, as I'll kind of explain. Corn is 113.5 per bushel and $3.15 per bushel for average price. Wheat is 38 or 35.8 per bushel and $4.45 per bushel there for average price. We're going to take and we're going to use those in order to create our objective function. So here I've taken those two things that I've got for wheat and corn and put them together in order to multiply them in order to get my number for x and my number for y. We're going to use these as our objective function. And what does that actually tell us? Well, if we take and we graph all of our inequalities, we're going to go ahead and we're going to graph all of our inequalities as you see here. The places labeled A, B, C, and D are what we call corner points or vertices. These corner points or vertices are where maximum and minimum profit are actually achieved. So what that does then is it shows us that we want to take those corner points and plug them specifically into the profit function. We take a look at all those numbers that we plugged in. We end up with 80/40 being our highest max profit, which essentially means that 80 acres of corn and 40 acres of wheat create the max revenue of $34,974.80. So what does the corner points actually tell us? The corner point principle. It's the maximum and minimum values of the objective function that occur at the vertices of the feasible region, something that we just kind of looked at. If you look at example number 2 in your notes, find the maximum and minimum values of the objective function given the set of constraints below. We're specifically honing in on those corner points. We first take our inequalities and graph Now, if you notice, I created an XY chart to get the x-intercept and y-intercept because I feel like in standard form that's the easiest way to graph. And I was able to graph those along with the inequalities in the feasible region here on this graph. If you notice, I'm looking at those specific 4 points that create up this feasible region as I put over here on my little chart. From there, I also put those into my objective function, and I find out that my highest is going to give me 60, and my lowest, obviously, is going to be 0. Then we're asked the question, can an unbound feasible region have a minimum or a maximum? So what if we wanted to shade in the whole region that's over here in white? Because it's unbound, we could definitely have a minimum value, but we would have no max because that max would continue on forever and ever. Now let's put it back all together in example number 3. A tray of corn muffins requires 4 cups of milk and 3 cups of wheat flour. A tray of bran muffin takes 2 cups of milk and 3 cups of wheat flour. There are 16 cups of milk and 15 cups of wheat flour available. The baker makes a profit of $3 per tray of corn muffins and $2 per tray of bran muffins. How many trays of each should he make in order to maximize the profit? First thing that we want to do is define our variables. So in this situation, a lot of you are probably thinking, well, milk and wheat, that's the biggest things. The milk and the wheat flour, those are going to be our X and Y. But actually, if you read this last statement, we're looking for how many trays of each. The trays, not how much milk or how much wheat we have. Because really, we know how much we have per tray of corn muffins and per tray of the bran muffins. So we're going to define our variables and let X be the tray of corn muffins and Y be the tray of bran muffins. From here, we're going to use what we know about the milk and how much milk we have, and the wheat flour and how much wheat flour we have, to create the 2 inequalities. Just as a reminder, X is greater than 0 and Y is greater than or equal to 0 are both those unmentionables because we cannot have a negative answer. Once we're able to get those inequalities, then once again I created my t-chart to show the X and Y intercepts, and then I was able to graph. So after we're done graphing, we need to definitely look at our objective function. Remember, objective, for most cases, is stuff that we're getting, something that we're getting back. So in this case, it's going to be profit. The baker makes $3 of profit on the corn muffin trays and $2 per tray on the bran muffins. So P is equal to 3x plus 2y. From there, I use that profit function and my corner points I have in my graph in order to get my objective function or my maximum profit. So as you can see here, maximum profit of $13 is with 3 trays of corn muffins and 2 trays of bran muffins. Moving to example 4. I'm going to go up to example number 5. So at any time, if you feel like I'm going too fast, you can always rewind this video. Or if you're like, you know what, I kind of get it, you can go ahead and shut it off. Sole Shoes manufactures sneakers and clogs. Each pair of sneakers requires 3 minutes of cutting time and 7 minutes of assembly. Each pair of clogs requires 2 minutes of cutting and 8 minutes of assembly. Sole Shoes have 12,000 minutes of cutting time available each week, 34,000 minutes of assembly available each week. Sole Shoes make a profit of $10 on each pair of sneakers sold and $8.50 on each pair of clogs. How many of each shoe should the company produce per week to maximize profit? Find the intersection algebraically. Here we're mainly looking for our maximum profit. So the first thing we want to do again is to find our variable. How many of each shoe should the company make? Right there's a big thing that tells us what our variables are going to be in each shoe. So we're going to let X be our pair of sneakers and Y be our pair of clogs. From there, we're going to look at cutting time and assembly in order to create our 2 inequalities. Again, X is greater than or equal to 0, and Y is greater than or equal to 0 for the n-dimensionals. Now, what I did from there is I found out what the x and y intercepts were again. And if you notice that for specifically the second one there, the 4,857 and the 4,250, those are a little bit more, not as precise. So just kind of go with the flow there and know what those specific numbers are. And you kind of eyeball where you're going to put them on your graph. You do not have to scale the same as me. This is just the way that I scaled personally. But if you notice, I've got 3 of the 4 points, and I've had a little tough time trying to find out what this point actually was. So whenever it says solve for that point algebraically, we're going to use elimination method in order to solve out and see where that point is. So taking out the inequalities for a minute, if I want to find a point of intersection between 2 lines, I can use graphing, substitution, or the elimination method, going back to systems of equations. So in this case, I used elimination method because I thought that would be easiest. And I took my one equation that I had, the 3x plus 2y is equal to 12,000, and multiplied it by -4. You see this then, as I put it back underneath, that it becomes -12x minus 8y is equal to -48,000. Add straight down, the y's disappear, and then we end up with x to be 2,800. I'll go ahead and I'll plug that back into my equation to get y to be equal to 1,800, and that gives me my point that I have for my line. So coming back over here, I put my 4 corner points, and then of course I've got to look to see what my objective function is. Remember, objective function is mainly based off of profit. So in this case, sole shoes make a profit of $10 in each pair, and clogs are $8.50. So 10x plus 8.5y. Plug that information back into my corner points, and I end up with a max profit of $43,300 when 2,800 pairs of sneakers and 1,800 pairs of clogs are made and sold. All right, last one that I kind of want you to look at a little bit is the Algebra 2 quiz. And we actually didn't, I don't think, got to this today in class, so this is where I'm going to stop because I think this is a good stopping point for us to go over it if we've been there. All right, and that's all I've got for you today. If you do have any questions on numbers 5 through 7, please let me know anytime that we're in class. Otherwise, have a great day.